Have you ever wondered how engineers design bridge supports or how architects ensure walls meet at the perfect angle? In geometry, lines don't just exist in isolation, they collide, they cross, and they create angles. Today at STEMBridge, we are diving into exercise 8.3, where we move beyond just drawing lines to calculating exactly how they interact. Whether you need to find the point where two paths meet or the exact degree of their tilt, we're going to break down the intersection laws that make you a master of the coordinate plane. Mastering straight lines from angles to intersections, a step by step guide to building your geometric toolkit. Module 1, the geometry of angles. Our first goal in this video is to master the fundamental skill of measuring the angle between any two straight lines. Whether we are given slopes, points, or full equations, our core principle must remain the same. This will be our master tool for finding angles, which is tangent of theta is equal to m2 minus m1 divided by 1 plus m2 into m1. Here the theta is the acute angle between two lines, m2 is the slope of the second line, m1 is the slope of the first line. The absolute value brackets ensure that we need to find the acute angle. Finding the angle from slopes. In our first problem, we need to find the measure of the angle from line 1 to line 2. If the slope of line 1, let's say m1, is equal to negative 0.5 and the slope of line 2, let's say m2, is equal to 4.5. We will substitute these values into our formula and simplify the numerator in denominator. After we get the value, we can calculate the final value of theta by taking the tan inverse. So our angle of theta will be 75.96 degree. Finding the angle from points. When given points, our first job is to find the slope, which is by using y2 minus y1 divided by x2 minus x1. In the second problem, we need to find the angle between line 1 and line 2 if line 1 joins negative 2, negative 1 and 3, 4, while line 2 joins negative 1, 3 and 4, 8. For each of the following points, we will gather the gradient. Calculating the gradient for the line 1, we get 5 by 5, which is 1, and for the second line, we also get 5 by 5, which is 1. Now we will apply the angle formula 1 minus 1 divided by 1 plus 1 into 1. That is 0 by 2 or simply 0. So if we take the tan inverse of 0, we will get our theta. So our acute angle here is 0 degree. This means that our lines are parallel with each other. Now angles from line equations. For equations in the form ax plus by plus c is equal to 0, we will first find the slope using m being equal to negative a over b. In this problem statement, we need to find the angle between the lines. For line 1, we have 3x plus 2y plus 5 is equal to 0, and for line 2, we have 2x minus 3y plus 8 is equal to 0. So for the first line, we will find the slope. For 3x plus 2y plus 5 is equal to 0, our a, which is the coefficient of x, that is 3, and b, which is the coefficient of y, is 2. So if we divide negative a over b, which will be negative 3 by 2, that is our slope. For the second line, we can also find the slope by gathering the values of a and b. Here a is 2 and b is negative 3. So if we divide negative a over b, we will get our slope, which is 2 by 3. Now if we analyze the slope, we will notice that m1 into m2 is equal to negative 1. That means that since the product of our slopes is negative 1, these lines are perpendicular and the angle theta will be 90 degree for any perpendicular line. Sometimes analyzing the slope gives you a shortcut. Now let's move on to module 2, which will be the point of intersection. We've learned how to measure the space between lines. Now we'll discuss the single exact location where they cross. This is where two lines become one point. Our master tool for finding intersections. The point of intersection, which is x, y, is the one and only solution that makes both lines' equation true and at the same time. We can use both methods. The first is the elimination method and the second is the substitution method. In the elimination method, we add or subtract the equations to eliminate one variable. It is best when the coefficients are opposites. While the substitution method is used to solve one equation for one variable, suppose y is equal to mx plus c, and substituting it into the other equation. Now we need to pinpoint the intersection. In this problem statement, we need to find the point of intersection of these two lines. The first line is 2x plus y plus 1 being equal to 0, and the second is x minus y minus 4 is equal to 0. If we move the constant in the both equations, which is positive 1 in the first line and negative 4 in the second line, then we can eliminate one variable. Let's suppose we want to eliminate y, and then we can add the two equations together. So here we get 3x is equal to 3. If we divide 3 on both sides, here x will be equal to 1. Now using the value of x that we just found, we can use either of the two equations if we choose the first equation or the second. Let's choose the second equation for now. Placing the value of x in the second equation, we will get the value of y, which is negative 3. That means our point of intersection is x comma y, or simply 1 comma negative 3. Now we will move on to module 3, which is advanced applications. We can now find angles and intersections. It's time to combine these skills to solve more complex problems involving not just two lines but an entire family of lines. The concept of family of lines. An infinite number of lines can pass through a single point of intersection. We can describe all of them with one elegant equation, which is L1 added with KL2, and that will be equal to 0. Here k is a parameter. Every value of k defines a unique line that passes through our intersection point. Our goal in these future problems will be to find the specific value of k that meets an extra condition. Now we will find one line in the family. We need to find the equation of the line through the intersection of 3x plus 2y plus 1 is equal to 0 and x minus 2y plus 3 is equal to 0, which passes through the point negative 1 comma 0. Firstly, we will set up the family equation which we learned from the previous slide, which is L1 plus KL2 being equal to 0. Here L1 will be our first equation added with k multiplied with the second equation. Now we will use our coordinates negative 1 comma 0 into our equation. We get the value of k as 1. Now to find the final equation, we can substitute k as equal to 1 back into the family equation. That means 4x plus 4 is equal to 0 or x is equal to negative 1. Now we will use slope to define the line. Here in another problem statement, we need to find the equation of a line through the intersection of 6x plus y minus 3 is equal to 0 and 2x minus y plus 13 is equal to 0. However, instead of having coordinates, we have a slope of 3. Firstly, we will set up our family equation and then we will rearrange it to find the slope, which means grouping x and y terms. That means our slope m is equal to negative 6 plus 2k divided by 5 minus 5k. If we solve for k here, we can set the value of our slope equal to 3. That means our k is 21 by 13. Again, if we substitute k is equal to 21 by 13 back into our equation and simplify, we will get our final equation as 3x minus y plus 6 is equal to 0. You've completed this lecture. We learned how to successfully build a powerful set of tools to analyze and understand the relationship between straight lines. The first tool for measuring angles was tangent theta being equal to m2 minus m1 divided by 1 plus m1 into m2. We found the slopes first. Then, for pinpointing intersections, we solved simultaneous equations. The key to this is to find the coordinate that satisfies both. And then we defined a family of lines. The tool which we used was L1 plus KL2 is equal to 0. We need to have an extragmentation, which is point or slope, to find the value of k and our final equation. From theory to practice, you now have the methods to solve every problem on this exercise. Practice is the final step to mastery. We've tackled everything from basic slope angles to complex lines passing through intersections. The key to exercise 8.3 is staying organized. Find your slopes, find your points, and use your formulas. If you're working through these specific problems in your textbook, let me know which number is giving you the most trouble in the comments. Don't forget to subscribe to STEMBridge for more step-by-step math breakdowns. You've got the tools, now go ace that geometry test.